What I want to talk about today is shifting the conics. We talked about the circle and the hyperbola and the ellipse last time, but those weren't shifted. They were centered up at 0, 0. Well, just like the parabolas, we started with the parabola, then we shifted them. Some other things too, but the same thing can happen on the conics. We can shift those right or left and do some things there. So that's what I want to talk about. But before I talk about that, let me tell you about a technique. Maybe you know this technique, maybe you don't, but it's called completing the square. So just a couple of real quick examples for that. What we mean by, when I talk about completing the square, what I'm talking about is actually, it's taking a trinomial, or making a trinomial be a perfect square. And by a perfect square trinomial, what I mean by that is something like, all right, so let's do x squared plus 10x plus 25. That trinomial is a so-called perfect square because if you factor it, if I factor that, that gives me what? X plus 5, x plus 5. So that's really the best way to write that would be x plus 5 squared. And so that's what we mean by a trinomial being a perfect square, is that it factors to be a square, binomial squared. All right? That's what we mean by completing, and that's, when we complete the square, that's what we want to make. We want to make a trinomial be a perfect square. All right, so the way we're going to use it, there's different reasons to do it, but here's how we're going to utilize it. Say I've got this equation here, and you can do this technique to solve this equation, but that's not what we're going to use it for. You'll see how we're going to use it in a second, but when I say let's complete the square here, what I mean by that is complete the square on the x's on the left-hand side here. And it's pretty easy to do if it's like that. If you've got, you do need the x to just be 1x squared, but that we won't have any that aren't in the problems I give anyway. But what you do, if this is 1x squared, then the middle term, you take half of it and square it. And that's going to go alongside the 6x there. So half of 6 is, of course, 3. And then to square that, you got 9. So I'm going to add 9 to the left-hand side. Now, it's an equation, and so what must I do to make this
do it to both sides.
Balance? Yeah. Do it to both sides. So I'm going to add 9 to the other side as well. And so that gives me, if you'll notice here, that gives me the perfect square, doesn't it? Because how does this factor? It would be x plus 3, yeah, so that's x plus 3 squared. And that's the whole reason for doing that, adding the 9 thing there, is that makes it a perfect square. Trinomial square. And then that equals 16. And then, if we were doing this, the reason we would do it for that would be then we could solve that by square rooting both sides, using the square root method. But right now that's as far as we'll need to take it. You'll see why that is. Now the one other thing to note here is x squared minus 8x equals 10. And so if I want to complete the square on this one, what do you got there? X squared minus 8x, what do we do to both sides on that one? 16, add or subtract? Add 16, yeah.
Because it's squaring.
You're squaring it, yeah, so, but it works out. You just add 6, even if this is a negative, you still add that half of that squared, so half of 8 squared, you're still going to add it even though you do have subtraction between there. Now, what happens though when you factor it, what's the square here? X minus 4, yeah. If I factor that, it'd be x minus 4 times x minus 4, or x minus 4 squared. And so that's what kind of changes on this. If this is a minus, then this will be a minus on your square. And that equals 26. But you're still going to add, but when you factor it, if you will, it'll be a minus. All right? So we'll come back to that in just a second. Yeah, let's talk here about then shifting constants. Specifically, we're going to shift the circle and the ellipse and the hyperbola. It applies. Well, actually, we start with what we've done. So if I was talking about the shift on this particular, this is just a parabola that's been shifted. What's the shift there?
Up to.
Inside shifts it right or left?
Right.
Two to the right. And it goes opposite what you normally think. Yeah, inside the parentheses with the x, which that would be important, that shifts it right or left. And the minus 2, if you will, goes 2 to the right. Plus 2 makes it go 2 to the left. And the other thing we could talk about there that's kind of applicable here is specifically one point that shifts there 2 to the right is the vertex, right? The vertex for x squared is 0, 0, right? This vertex, where is it? Well, it's 2 to the right, right? 2, 0. That's what this graph. So the vertex is shifted, and that's kind of where what we're going to do with this is talk about that special point. In this case, the vertex, but for ellipses and circles, hyperbolas will be the center. But all right, now how? And then of course, if we do the plus 3 inside with the x, that makes it go 3 left, and so that would shift the vertex to negative 3, 0. Anyway, all right. So we've already been over that, just reviewing that. All right, so let's think about this. Start all over here. So if I've got x squared plus y squared equals 4, what kind of graph is that?
Circle.
That's a circle. All right, so we've got a circle centered at 0, 0. Radius, square root of 4, 2. Radius 2. So if we know what we're doing, that's an easy thing to graph. If you can scale it off, kind of square it off. Okay. All right, so let's talk about this one. X minus 3 squared plus y minus 5 squared equals 4. So there we have still, right, we've got x squared and y squared. If I fold all that out, I would have the x squared plus the y squared. So what I'd like for you to realize is this graph is very much like this, except what? What's this going to do?
Shift.
That's going to shift it, right? That's going to shift it, just like on the parabola, that's going to shift it 3 to the right. Yeah, the minus 3 goes, if you will, 3 to the right. So that shifts it 3 to the right. Now, we've got a y minus 5. Well, obviously, that's not going to shift it right or left because it's subtracted from the y, but the x makes it go right or left inside there. So guess what the minus in the
Up or down.
makes it go up or down. Now guess which the minus 5 does?
Goes up.
It goes up, yeah. This is 3 to the right, this is 5 up. Well, specifically, if I shift my center 3 to the right, 5 units up, that puts my center where?
3, 5.
3, 5, okay? Yeah, so this is a circle. The center is 3, 5. Where did the 3 come from? Well, it came from right there. Where did the 5 come from? It came from right there. So in this form, you've got the center. You can read the center right off there. You just have to remember, it's kind of the opposite of what appears there because of the shifting, the way the shifting works. The radius is still going to be that square root of 4, 2. And so yeah, that's how we graph this thing. We read the center right off of that. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I think is what we'll need there. So at 3, 5, there's my center. And so we know it's a circle. And so how do we finish the graph off? Well, we do like we did here. Go out 2 units right and left, 2 units up and down. There's our graph. So we go from the center 1, 2, put it out there at 5, back to here, which would be right at 1, down 2, kind of square it up, and then up to, there's our center, our circle. Okay? Just based on the shifting. So, we used H and K before, right, with the parabolas. We used HK. For parabolas, the HK is the vertex. Well, for circles and ellipses and hyperbolas, the HK is the center. So, in general, here's the standard form, we might call it, of a circle. X minus h squared plus y minus k squared equals r squared. That, if you have that equation like that, that's a circle. The center is h comma k, and the radius is r. Square root of that. Okay. Now, again, let's note here, all right, so if I've got x plus 1 squared plus y plus 2 squared equals 9, what do you got there? Well, that's a circle. The center
Is that -1?
-1, -2, yeah. If you got a plus 1 with the x, then the h, or the x value of the center, is -1. If it's plus 2 with the y, then it's -2 for the k, or the y coordinate of the center. You do the opposite sign, if you will, of what it appears in the equation. Because of the shifting. That's going to make it shift to the left. That's going to make it shift down. So your center is -1, 2 there. And then the radius there is 3. And yeah, again, so you just go 1, 2, 3, 4, 1, 2, 3, 1, 2. So you go to -1, -2. There's my center, right? And then once you find your center, then since it's a circle, you just go out 3 all directions. So right 3, just put it right there at 2. Left 3, put it at -4. Down 3. Up 3. 1, 2, 3. 1, and then yeah, right, yeah, okay. My skills are not the best, so anyway, something like that. Okay? Good news. Works the same way with ellipses.
Yay.
Yeah. Very same thing for ellipses. But before we do that, before we get to the good news here. All right, so the other thing we wanted to also, on the circles anyway, maybe a little bit with the ellipses, maybe hyperbolas, but also let's go the other way with this. All right, so those two problems we just did were, here's the equation, what's the graph look like? Well, this next one is, so here's what graph I've got, what's the equation of that? So this first one's not that hard if you know what you're doing again, but all right, so find the equation of the circle with center 5, -3 and radius 7. So essentially this is going the other way. A while ago we said, well, here's the equation, what's the center and the radius, and then you can graph it. Well, in this case, we've got the center and the radius, what's the equation of that? So, just going the opposite direction, if you will, of this. Well, since it's the equation of a circle, let's start with that circle radius, center radius form, standard form, maybe we could call it, but yeah, if it's an equation of a circle, I know it's x minus h squared plus y minus k squared equals r squared. And I've got the pieces I need, right? Because in this case, again, the h and the k, that's the center. So isn't this h? Isn't that k?
Mm-hmm.
Yeah. So I've got x minus 5 squared, y minus k, so k is -3, so that'd be y minus -3, which is y plus 3 squared equals r squared, 7 squared, which is 49. Right? So we've got that information. Find the equation of a circle is really easy. Now, take it one step here further. Find the equation of the circle with center -4, 2 that goes through 9, 1. Find the equation of the circle with center -4, 2 that goes through 9, 1. Well, again, we've got a circle, so this is the format probably that we want to go with because the center is shifted a little bit. All right, so this is my h, that's my k. So x minus h, so that'd be x minus -4, x plus 4 squared. Y minus k, so that'd be y minus 2 squared. However, the deal on this one is I don't have the radius, right? The radius is not provided. And so I've got to work a little bit to figure that out. And of course, what I can do is use the point there. That's the way I'm going to find the radius. And one way to do this is, well, 9, 1, that's just an x comma y. We've kind of done this before. I think it was on the parabolas also. So we've got this x comma y. So can I plug those in for x and y and figure out the r here? Yeah. So plug this one for x, plug that one for y. And I can figure out the r, actually r squared. What was that, 13 squared plus -1 squared. 13 squared is 169. -1 squared is +1. And so 170 is going to be r squared, and you can go ahead and square root that. The radius would be the square root of 170, would be the r. However, in the formula, we're going to put in r squared anyway, so we're going to square that, and so we're going to get back to 170, right? So the equation is going to be x plus 4 squared plus y minus 2 squared equals r squared, so we're going to square that, which is going to give you 170. Good? The other little piece that you might have to consider, take for example, if I had, let's say I've got a circle through
The square root equals r, but that equals.
oh, let's make it
So you don't have to do that step right there.
1, 0, and
So 4 and a half.
let's make it
Yeah.
10, 0. So we have 2 points. Well, if they're in line like this, so we've got 1, 0 and 10, 0. And we know it's a circle, so it's going to go through that. Well,
The center would be.
yeah, if we put the center right in the middle of those two, right? Because that's where the center has got to go. Where would that be?
4 and a half.
5.5.
Let's see, 5.5. I believe so. Yeah. I didn't make it a nice even number there. It's an odd number, so yeah. You
It
just
should be 4 and a half because there's 9 in between.
there's 9 in between,
That's
but we
right.
start at 1, so you add 4.5. It's 4.5 here and
Okay.
here. So if we start at 1, that would put it at
Okay.
5.5. Yeah. It is 4.5 units to that point, but it's
Yeah.
the actual.
You started on 1.
We started at 1. Yeah. So yeah, you can figure out. Yeah. So the center here would be at 5.5, 0. Or fraction if you want there. And then the 4.5 is what?
The radius.
That's the radius, yeah. So sometimes you might have to figure those things out. All right, so that would be x minus 5.5 squared plus y. Oh, and then y minus 0 squared equals then 4.5 squared, which that brings up another point here. Y minus 0 squared, that's just what? Y minus 0 squared, how could I simplify that?
Just y.
Just y squared, yeah. So the x minus 5.5 squared plus y squared equals 4.5 squared. Somebody got that for me? 18 something? 20.25. Didn't add enough there. So maybe something like that you have to do there as well. All right. Any questions on that? Good? All right. Yeah, so like I said, we can also shift the ellipses, but they're going to work much the same way. Oh, still got one more. Getting way ahead of myself here. All right, fine. Let's do this one. x squared plus 4x plus y squared plus 8y minus 10 equals 0. All right, so yeah, this is also a circle. And basically I can tell that because I've got x squared, y squared plus there. 1x squared, 1y squared. That kind of tells me it's a circle. And so yeah, this is going to have a center and a radius, and use that then to graph this. But obviously I need it in a better format would be the center and the radius format, right? The x minus h squared plus y minus k squared equals r squared. That would be a better format, and I could tell a whole lot more about this circle, and it would be obviously a circle. Well, what that amounts to is, what I need to do is a couple of completing the squares. I need to complete the square on the x's, and I need to complete the square on the y's. Now, this minus 10, we'll call it, maybe just call it, it's some extra there if you want. Best thing, I think, anyway, is move that 10 over to the other side, because I'm going to complete the square on the x's, complete the square on the y's, so I'm going to leave a space there. X squared plus 4x space plus y squared plus 8y, leave a space. And then let's add 10 to both sides. So the right side is 10. All right, with me so far? All right, so yeah, if I complete the square on those x's, how do we do that? Half the middle term squared. If this is 1x squared, you take half that middle term and you square it. So half of 4, 2 squared, it's back to 4, yeah. So I'm going to add 4, but to make this legal, I have to do that to the other side, plus 4 the other side. And then do the same thing on the y's. Half the middle term of the y's, 4 squared would be 16. So I'm going to add 16 to both sides as well. That gives me some trinomial squares, because perfect squares, trinomials. How does that factor? Well, it'd be x plus 2 times x plus 2, or x plus 2 squared. Factor that, it'd be y plus 4, y plus 4, y plus 4 squared with it. And that equals 30. So there's my center. -2, -4, right? Because you do the opposite. The radius is the square root of that. Square root of 30 if you wanted to approximate it. Do that. All right? X squared plus y squared minus 10x equals, x squared plus y squared minus 10x plus 9 equals 0. Also a circle, got the x squared plus the y squared there. So let's complete the square to get into this format here. So what would I do on that one? Move the 9, all right, so I'm going to minus the 9 both sides. Do a little bit of rearranging here. I need the x's together, so I'll just make it x squared minus 10x, and then plus the y squared, leave a little space there, plus the y squared equals -9. Complete the square on the x's. And that just means take half the middle term and square it. Half of 10, 5 squared plus 25. Do that to both sides. The y squared, nothing to do there, right? Because there's not an extra y term on that, so you don't have to do anything with that. So if I factor then, this completes the square here, so that's x minus 5 squared plus y squared equals -9 plus 25 is 16. And And so the center, when the center and the radius, the center would be, we do the opposite, 5. Now what about the y?
0.
Yeah, there's nothing subtract from the y, so the y value of the center, the k, is 0. And the radius, of course, is the square root of 16. All right?